Hello, everybody. Welcome to what is it, week 12? Something like that, of environmental concerns. I'm Michael Leclerc, and today we're going to be talking about terrestrial environments. So I'm actually proud I got the hands right this time. So, terrestrial environments and basically how climate change has been impacting our terrestrial world, which is basically looking at the Earth, not water, like the aquatic environment, which is what we'll be dealing with next week. So, without further ado, these are the topics that we're going to be getting into. So, there's quite a few of them. There's even some that I'm not going to be discussing this week, but these are the main ones for this week: desertification, soil erosion, crop yields, air quality, urbanization, invasive species, deforestation, acid rain, and then extreme weather events at the bottom. All of these are impacts that climate change is having on our terrestrial environment. So first off, we got desertification. So what is desertification? It's kind of, if you look at the root words there, you got desert in there, you got ification, I guess, if that's considered a root word. But basically what we're looking at is that deserts are being formed or they're growing. So as the first point here says, land degradation, in which biologically productive land is lost due to natural processes or induced by human activities. And that's important to note because desertification itself is actually a natural process that does happen over time, but the process of climate change and just human activity itself can speed this up quite a bit. So there are a couple main things that can cause desertification. You got your droughts, which, you can imagine, is pretty straightforward. It turns arid land to unproductive, barren soil. A desert is known for being quite dry, not the driest though, remember that's tundras. But because they are so dry, droughts are obviously something that would create a desert. If plants aren't getting the water they need, then deserts can soon follow. Overgrazing and overcropping are other examples of something that can cause desertification. Overgrazing and overcropping being you have way too much livestock or you just have too much plants that are just soaking up and taking up all of the plants, or they're just taking up all of the nutrients that are in the soil without any nutrients remaining in the soil. By overcropping, what ends up happening is that they can't be replenished enough to keep the production of those plants going, and those plants eventually, future generations, would starve out from lack of nutrients. And then of course we have deforestation. The quickest way to make a desert is just chop down everything or get rid of everything that's there. So if you remove the natural vegetation, it actually removes the cover, which increases the likelihood of fires and disease. So this is actually a good example of desertification. We have the Sahel region. I'm sorry if I'm pronouncing that wrong. Sahel. I'm going to say Sahel. It's in a region in northern Africa that is experiencing desertification. So for hundreds of years, the region has experienced regular droughts and mega droughts. And a mega drought is just basically a more extreme drought, something that lasts for decades as opposed to something that lasts, a couple years or even just a couple seasons. The Sahel region itself is a victim to overcropping, to overgrazing, as well as soil erosion, something else we're going to talk about, and overpopulation. Dust storms are also extremely frequent over here, and these dust storms actually will displace sand and dust, which further causes desertification. One of the trademarks things that you think of when you think of a desert is dirt and dust and sand. So it makes sense that if it gets spread over and takes over areas, then that's effectively becoming a desert as well. So the government is attempting to fight desertification. They have something that's called the Great Green Wall. It's an initiative that they've started. This has been in the works for a little while now, at least. And the plan is to plant a wall of trees that stretches across the entire Sahel. So if you think about it, one way that we can combat desertification is by just increasing the plants that are in the areas that are threatened to become deserts, right? It can't become a desert if you have a productive and well-established forest or just green cover in general. Although planting this wall of trees is still part of the goal, the project has expanded quite a bit, and it also now includes other things such as water harvesting techniques, greenery protections, and improving the land use techniques that are used by the people of the area. So as of September 2020, the Great Green Wall, however, has only covered 4% of the planned area. But if you think about it, 4%, remember, Africa is a huge place. That's still 4 million hectares worth of planted trees. So not too shabby in the short term, but hopefully they continue to get those percentages and bump them up a little bit. It's an effort by several of the countries that make up that region that have to work together to create this green wall. The next thing we're going to discuss is soil erosion. Soil erosion actually will cause things like desertification, as we just discussed, but it'll actually influence other things, especially in aquatic environments, as we'll talk about next week. And the reason for that is because soil erosion is, in its simplest form, soil eroding away, which is, probably a pretty poor definition because I'm literally using the word in its own definition. But basically imagine you have your soil, you have your plants, as you can kind of see in this picture here, and the soil is removed. And the two main ways that this happens, this removal, is through wind and through water. So as you can probably picture yourself, right? If you have your soil, the wind will push the soil away. If you have your soil and the water, whether through a flood or through rain or what have you, just kind of collects the soil, raises it up. You've seen, muddy water, and it takes the soil away with it. The topsoil is the most essential part when it comes to your livestock and your crops, because that's what actually contains all of the essential nutrients for the crops to grow. So if it's taken away, then you're left with, basically, in some cases, like desertification, you're left with sand and inarable areas that just can't be, used for crops. This soil-laden water, if it's water that was the means of actually taking away the soil, can travel downstream, as water will do, and it can prevent streams and rivers from flowing smoothly and eventually lead to flooding. And the reason that happens is because of the way water hydraulics works. Again, I'll talk about this more next week, but in a very brief summary, quick moving water will hold and suspend water in it. The particles in it. So as long as the water is moving quick in a river, for instance, the soil is going to continue to move downstream. As soon as you reach a bigger area where the water gets to spread out more, whether it's a lake, whether it's a big turn or bend or whatever the case may be, that soil is no longer moving quickly with the water and has a chance to start settling out. As it settles out to the bottom, you can imagine this is a longer term factor with soil continuously happening repeatedly. The soil will continue to build up until you can start getting flooding, or you can even get entire rivers just being shifted in direction. They don't flow the same way anymore. And as it mentions, soil erosion degrades land, which means it can support fewer plants because, as I said, the soil contains the essential nutrients. And if the soil is no longer there, it can't provide nutrients for those plants. Soil itself also sequesters greenhouse gases. It holds in carbon. So by removing that source from it, then you're also preventing potential sequestration. I don't know why I keep hitting the keyboard. It's not doing anything. The next one kind of works with soil erosion as well. You'll notice a lot of these are pretty interlinked together, and that's on purpose. It just shows that the world we live in is very intermixed. It's not as simple as everything is isolated. You're affecting one thing that doesn't affect anything else. Everything kind of works together in the grand scheme of things. So crop yields are obviously something that would concern us directly because we eat the crops that we grow, whether it's directly we eat them or we feed them to our livestock or we feed them to our pets. Crops are pretty important. And increased temperatures and elevated carbon dioxide concentrations due to greenhouse gas increases and due to climate change can cause radical shifts in crop yields for different plants. It can be good for some plants, which might seem good, and it can be bad for others. And that's because plants need the following things to thrive. And this list should probably be no surprise to anybody. You need sunlight, you need the proper temperature, you need moisture, you need air, and you need nutrients. Those 5 things are essential for plants to grow. And if one of those or a couple of those are out of whack, you're going to start getting less. And then this video kind of highlights what I'm talking about.
We're already feeling the effects of climate change. Intense heat waves, longer fire seasons, droughts, and floods. The impacts of a warmer planet are all around us. And as global temperatures continue to rise, we'll experience even more changes to our planet. New NASA research suggests that with high greenhouse gas emissions, we'll see declines in global crop yields for maize, corn, as early as 2030. Shifting rainfall patterns, higher temperatures, and increased atmospheric carbon levels are likely to affect where and how much of staple crops like corn, soybeans, wheat, and rice can be grown. Using multiple highly accurate supercomputer models, researchers projected future global conditions based on greenhouse gas emissions. They ran these results through models that simulate how crops respond to changes in things like rainfall, temperatures, and atmospheric carbon dioxide. By using multiple computer models, the teams could compare results and be more confident in what they learned. Overall, corn and wheat showed the clearest results. By 2069 through 2099, global corn crop yields could decrease 24%. Corn is grown around the world, with large quantities grown in countries close to the equator. Rising temperatures in this region will put stress on those plants, leading to lower crop yields. Wheat, on the other hand, grows mostly in more temperate regions, like the northern US and Canada, North China Plains, Central Asia, Southern Australia, Europe, and Russia. Warmer global temperatures and higher atmospheric carbon dioxide could increase wheat crop yields up to 17%. However, these increases will likely level off by 2050 or so. Changes to our global agriculture are likely to happen relatively soon, even in scenarios where we significantly lower greenhouse gas emissions. The more we understand about how our global food systems will change in a warmer climate, the better prepared we can be.
Okay, so what was important to show in that one particularly, if I actually, can I get the right moment? Can I? Get rid of this X thing here. So one thing that I want to point out with this is you can see that it's not clear cut, right? Like they said that wheat is going to be increased in like production, whereas maize is going to be less, or corn is going to be producing less. But you can see there are some green spots, right? For corn in particular, you can see there's some red spots even for wheat here in particular. But it's just overall that obviously wheat's going to increase in how much we're making, and corn we're going to be decreasing less. And that's due to climate change again, and where the heat is centralized. So corn in particular likes those warmer climates. So it makes sense that in spots that, it likes a colder type climate than wheat typically does. So you're going to see that impact a lot more, where as temperatures rise even just a little bit, or carbon dioxide concentrations increase a little bit more, corn is not able to sustain in spots where we used to be able to grow it. Just won't be able to sustain it anymore. Likewise with wheat, it's kind of the opposite story, right? Where the temperature in a spot where it couldn't be grown before now all of a sudden becomes even better, or maybe a spot that used to be good is now just fantastic.
Overall,
and the next topic we got here is air quality. So, production of greenhouse gases and ground level ozone caused from smokestacks and tailpipes mixing with the air. That's what we're talking about when we're talking about air quality. And this is kind of associated with 4 different types of air pollutants. You have your nitrogen oxides and your greenhouse gases as a result. You have your ozone, you have your particulate matter, and you have your allergens. Of these 4, nitrogen oxides are pretty harmful. Ozone is obviously also harmful. To be honest, all 4 of these are harmful for mostly the same kind of reason. A lot of them will impact our lungs and our respiratory systems. And that makes sense because we're breathing them in for the most part. It's air quality, right? So nitrogen oxides, to start off with, they're the harmful byproducts of fossil fuel consumption. So this also includes, obviously, your carbon, your sulfuric, and all that stuff. It's a lung irritant, which, as I said, should not be a surprise to anybody. And it can also undergo chemical reactions in the air to transform into other kinds of harmful pollution. We'll actually briefly discuss one of these in a little bit. Ozone is produced by a chemical reaction that happens more often at warmer temperatures, and that's because it also needs that. If you'll recall back from one of our earlier presentations, ozone is actually created when oxygen molecules are impacted by UV light, and that impact causes the ozone to split apart, or the oxygen, to split apart, and the one oxygen atom mixes with a molecule to get your O3, or your ozone. Ozone is also pretty popular, sounds like the wrong word, so I guess I'll say infamous, for being the primary contributor to city smog, which is more prevalent during the warmer summer months. I'm sure people have seen pictures of some of the Chinese cities or even like at Los Angeles during the summer where they seem to have like that smog over top of the city. Toronto's had it occasionally. It's probably most cities are not exempt from it. And ozone is the primary cause of this. It's also an cause of inflammation of the lungs. Particulate matter is, as the name suggests, those small particles. Those small particles that float in the air that come from car exhaust or industrial processes. The tinier the particles get are actually the more dangerous ones because they can move further into our lungs and cause health problems. So in a nutshell, if you think of your lungs as, well, I mean, everybody knows your lungs are necessary for breathing, but what people tend to sometimes not necessarily forget, but just kind of not think about, I guess, is that they're basically the membrane that separates your blood, which flows through your whole body, and the air, which is where the oxygen comes in from. So the way that the lungs work is, if you think about the different types of arteries that we have in our body, it goes, your arteries, your arterioles, to your capillaries and stuff like that. Basically, you start with your bigger arteries, which are where a lot of your blood is found. It's the bigger pipes, I guess we'll call them for simplicity's sake. And that gets broken down into your arterioles, which are smaller and spread out, and then down to your capillaries, and then down even smaller and smaller and smaller and smaller until it's almost down to like the cellular level. And that's where you have your blood and your oxygen mixing with that layer. So if you have particulate matter that is able to get into the smaller areas, that's more dangerous because those can block up things. Those can cause irritation, and then those can cause further health problems. It's not the same thing exactly, but that's kind of part of the issue with, like, if you get a blood clot in your lung, it starts off small and then it slowly builds and builds and builds, and it takes up more space. If it starts off small, usually it can be solvable, but okay, maybe it's not exactly the same thing. But essentially what I'm getting at is if it's a smaller particulate matter that can get into smaller parts of your body, that it's harder to remove. It's harder to find and remove. And that's not necessarily from a surgery point of view. That's just in a general point of view. And then, of course, we have our allergens is the last one. Anybody that has allergies, you know how much of a hassle they can be. Myself, I'm allergic to pollen. During the spring, particularly when the flower pollen starts coming out, I just become a runny-nosed, teary-eyed mess. So allergens actually become worse due to climate change because you have warmer temperatures and you have longer growing seasons. You have longer growing seasons, you're going to have more pollen. And I know, if I'm speaking for myself personally, I can already picture the headache forming in my head right now because of all the sneezing and, teary mess that I'll be because of that. Urbanization goes hand in hand with air quality, but this is specifically to cities. So this chart actually demonstrates pretty well what I'm trying to get across with the wording on the right there. So they are major contributors to climate change, your urban areas, primarily because they're the urban areas that are going to be having your industrial sections that are producing all the, smoke and greenhouse emissions. So on top of greenhouse gases they expel, the urbanized areas are also impacted by what's called the heat island effect. And so the heat island effect, in a nutshell, is when an urbanized area experiences higher temperatures than the surrounding area due to man-made structures absorbing and re-emitting the sun's heat more than natural landscapes. I think I discussed this earlier in an earlier presentation, but you can picture the pavement, just pavement on the ground. If you're going to the beach or you're just barefoot or what have you, you know how hot pavement can get when it's absorbed sunlight for most of the day. You don't want to be walking on that barefoot, right? That's essentially what they're saying, is that all those man-made structures, it's not, concrete's concrete, whether it's pavement on the ground or it's that slab of concrete on your, that skyscraper, they're all absorbing and re-emitting that sun's heat the same way. So what you can see in this chart is that in rural areas or even just parks and, natural landscapes, the temperature stays lower or relative to what you would expect to find. But as soon as you get into suburban residential, it climbs. As soon as you get into downtown, it peaks because that's where all the concrete is and that's where all the sun's energy is basically being stored, is one way of looking at it. Next up, we have deforestation. Deforestation is something probably people are pretty familiar with. It's just straightforwardly the removal or clearance of a forest or a stand of trees from land that is then converted to some other use. So what we're going to be discussing is when we cause deforestation, what are the other uses that we're using for it? This does both impact climate change and is also impacted by climate change. So it's kind of a feedback loop. It's kind of the same idea with desertification if you go back to the first topic, where desertification is caused by climate change, but then desertification kind of spreads on its own. It's kind of almost like a virus in its own way that if you were to just leave it to its own devices, it would continue going. It's the same idea with deforestation. If you have an area that's deforested for one of the reasons that we're going to be discussing, it can continue to spread on its own sometimes, even if the original cause was man-caused, man-made. So the first one we're going to discuss is livestock. People basically tear down a bunch of the forest because they want to raise cattle or they want to raise just any sort of livestock. Normal farming use, so when you're thinking about your typical mom and pop farmer, aren't necessarily the issue with this. It's more the fast food companies, so your McDonald's, your A&W, your Burger King, those types of places that do the same thing, but on obviously a much larger scale because they're looking at, millions of cows, for instance, just due to the amount of burgers they're putting out and producing day by day, right? You have agriculture, which similar to livestock, but in this case, we're talking about the plants. So agriculture actually has a pretty harmful way that they do deforestation, which is called slash and burn. It involves basically chopping down all the trees and then you burn the trees, and that's a better way they look at it, instead of picking up and chopping down the trees and then chopping them up into lumber or something for other uses. They just burn the trees entirely to clear it. One reason why they do this is because when you burn something, or burn trees in particular, all that energy and all that what's the word I'm looking for, the nutrients, I guess, is from the trees that were burned, becomes fertilizer for the soil. And so it actually enriches the soil quite a bit to make the agriculture a lot more effective. Unfortunately, as the last point down at the bottom here points out, the soil that's fertilized in this way only remains for a few years. It's not like they're constantly burning down trees all over the place to do that. So what ends up happening is that eventually the soil becomes unable to be used just because it's lacking in nutrients at that point. So they abandon that farmland, and sometimes it's used for cattle rearing, so it kind of moves back into that first one here, livestock. Sometimes they just abandon it and they don't do anything with it. One thing I want to point out is this whole point here, where slash and burn is dangerous for quite a few reasons. First off, of course, it's kind of sucky that they burn down all this area just for a couple years of production. But second off, the fire, it's fire. You can't always control it. So sometimes it can spread to unintended areas and destroy protective forest canopy. If it can push animals out of the forest, because obviously they don't want to catch on fire. If you destroy the forest by burning it down, it causes more sun exposure, which can cause intensified fires because just the added heat. And the smoke cover from the fires themselves actually prevents rainfall from extinguishing the flames itself. So the fires can just rage and they can just kind of go out of control sometimes. Not saying that always happens, but there's more bad than there is good in this case. So unsustainable logging. The name itself sounds pretty bad, right? Like, where in what universe is it a good idea to do anything really that's unsustainable? So in this example, clear cutting is when an area of forest is just completely deforested and it leaves no trees standing and leaves no trees alive. Sometimes they come back and they replant. They do that by remediating the area by planting trees, but monoplanting has its own set of problems. So what monoplanting is in a nutshell, mono, the root word for that, or meaning one, is that they plant a single type of tree. They plant hundreds of trees, if thousands, if not millions, but it's the same tree every single time. So say in this example, it's an oak tree. They plant millions of oak trees. That's great. We now have a forest of oak trees. But what happens is it creates an environment that only supports animals and plants that find food or shelter from that single type of tree, which in this case would be an oak tree. And that significantly reduces biodiversity because you're not allowing for the ability of anything else that would need, a second or a third plant to survive. They can't survive in that, and you basically have an entire forest of just that. Fires. So this kind of goes hand in hand with slash and burn. Unplanned, uncontrolled fires in an area of combustible vegetation. So this is not. So the difference between slash and burn and this one is that this is, as it says, unplanned and uncontrolled. So it's something that can spontaneously happen. Wildfires, essentially. I'm sure you've probably heard a bunch about this in LA suffers from it quite a bit. So the spread or how dangerously it can spread depends where the fire starts. And there's 4 main levels basically if you're thinking about a forest from bottom to top. So if you start at the bottom with ground fires, these fires are primarily fed by the roots and by buried organic matter. These can burn slowly for days to months due to just burning by the smoldering. And this is almost like you would just look at the soil and it would look kind of like coaly almost, I guess is the best way of putting it. You have your crawling fires, which are fueled by low-lying vegetation such as leaf litter, grass, shrubbery. These ones can spread quite quickly as well, but the further up we get is the more spreadability, I guess, they have. You have your ladder fires, which consumes material between low levels, so between your crawling area, and the tree canopies, so stuff such as your small trees, as well as the vines that hang from trees. And then we have our crown fires. These are the ones that burn suspended material at canopy level. So the ignition depends on the density of the suspended material. So depends how dense the tree cover is. But these can spread quite quickly because they're also impacted by the wind itself, which is usually, stronger the higher up you go. Mining, probably might be a surprising one for you guys to hear, but I mean, we have rare minerals all over the world, and underneath forests or jungles is probably no exception. So in order to mine, obviously to get to that earthen area where the minerals or whatever rare jewels or stones we want are, we need to clear cut and burn the entire area. So again, we got our slash and burn. Only once the ground is completely bare can large-scale mining operations and extractions begin. And obviously, that goes without say, destroys entire forests. You can see just in this picture here that basically everything's destroyed, and it doesn't look pretty, right? It's like basically a mud pit. Infrastructure is kind of a surprising one to hear. Infrastructure as in such as your road building. So you might think to yourself, well, a road is not that much. We have, millions of acres of forest. How big of a deal is a road? But just in the last 3 years, over 30,000 miles of road was built in the Amazon. And then you also have to consider corridors for electricity must also be created. So a single road might not be an issue, but when you consider how much road we're actually laying down, it starts actually really contributing. And plus, I mean, if you want to think long term or net result of everything, these roads are being built for a reason, right? We're building these roads to go to those farms, to go to those mines, to go to whatever the case may be. So there's that added part as well. Invasive species is an interesting one. It's one of the ones that I'm probably pretty familiar with just due to some of the background research I did back in school. Climate change can accelerate and introduce and spread invasive species. And there's 4 main ways that invasive species kind of get to their area. 5 actually. The 5th one I didn't include, but I'll mention it anyway. So you have extreme weather events. So more frequently occur, and they cause stress to the native species that actually belong there, which creates opportunities for invasive species to take advantage of that. Melting sea ice raises the sea levels. We'll discuss this one a little bit more next week as well, but it opens new shipping routes and therefore new pathways for invasive species. This is actually one how sea lamprey actually got into the Great Lakes and started causing havoc on the fish populations there. We'll talk about that one actually next week because that's a personal favorite of mine. You got the changing climate, which creates favorable conditions for increased spread of invasive species. And then you got increased carbon dioxide in the atmosphere. This is more plant oriented as opposed to like, a mammalian or reptilian or whatever animal type invasive species, but it leads to higher carbon dioxide uptake, which can increase herbicide resistance. So in some cases, something that we know is an invasive species might actually be more tolerant of herbicides because of the increased carbon dioxide. The fifth one that I didn't mention here is the big, probably obvious one, is that invasive species can just be introduced by humans being dumb and bringing something somewhere where it shouldn't be.
The climate changes currently taking place on our planet have brought about a rise in global temperatures and have created drought conditions in certain areas. Such climate-induced stresses weaken already established ecosystems, making it much more difficult for them to resist the attacks of destructive organisms. A good example of this is seen in the massive pine beetle infestations that are currently plaguing many mountainous areas in the western United States. When these beetles bore into pine trees, they leave behind a fungus that blocks up the tree's internal water and nutrient transport systems. When this happens, the tree's needles dry up, turn orange, and eventually drop off, leaving behind a largely dead forest. Very cold temperatures kill beetle eggs and larvae, which typically winter over under the pine tree's outer bark. But over the past decade, as global temperatures have risen, so have the average winter temperatures in the Rocky Mountains. And at the same time, their forests have become weakened by the prolonged drought. These two climate-related events have combined to allow beetle populations to increase quite rapidly and wipe out huge numbers of trees. A very similar situation is seen in certain hardwood forests in the U.S. involving another destructive insect called the emerald ash borer, a creature that was accidentally introduced to North America from Asia in the wood of packing crates. The borer's larvae feed on the ash tree's inner bark. This disrupts the transport of nutrients and water inside the tree, which soon destroys it. Very cold weather will kill the emerald ash borers, but generally milder winter temperatures and drier conditions in the forests have allowed them to proliferate and cause a lot of problems. In addition, the rising temperatures and drought that's been occurring in the Sonoran Desert region of North America are forcing some native species to migrate north or to higher elevations to places with cooler temperatures. As they move out, an invasive grass from Africa called bufflegrass is moving in. And because bufflegrass is better able to withstand prolonged dry conditions, it's beginning to crowd out some of the remaining native species. And this is altering the entire desert ecosystem.
Okay, so that last point, you might actually say, hey, we're getting more vegetation in the desert. That's a good thing, right? Yeah, not really, because the problem with invasive species in a roundabout way is that they're kind of so good at spreading or so good at reproducing that they just choke out life from everything else. So the problem with that last one in particular is that you might get a greener desert, which means you might remove a desert, but then you literally have an entire area with one plant that exists there because it will kill off everything else that tries to survive also. Another great one is the Phragmites that we have here in Canada. They basically look like the cattail kind of bushy kind of looking things that you might find along ditches and stuff, especially if you're driving on some of the country roads. They grow very thick together and very densely, And they have a very extensive like root system network that allows them to just kind of sprout up everywhere. The problem with them is that because they grow so densely and so thickly, everything else gets choked out. They take up all the nutrients, they take up all the water. So the Phragmites in this case survives, but absolutely no other plants can survive. Same kind of thing would happen here in the desert with that bushel grass that they were talking about. And that in a nutshell is kind of the main point with invasive species. They basically don't necessarily just, sometimes they'll just kill off a single thing, like something like the emerald ash borer that focuses on ash. Sometimes they're a little bit more dangerous and kill off everything else that can even potentially, live in that area. Keeping in mind too, even the emerald ash borer, by destroying all the ash trees, will also start impacting anything that depends on those ash trees as well. So it's multi-layered. The next topic here is acid rain. So this brings us back a little bit to those greenhouse gases that I was talking about with the nitrogen oxide that gets released. You can see that kind of at the top here. Basically, a chemical reaction is that the nitrogen oxides form with the water in the atmosphere, and you get nitric acid. Or you can have the sulfates here, your sulfur oxides, combining with water to create sulfuric acid. Acid obviously being pretty bad. When it combines with the water even more, you get your acid rain, which falls down and it can start dissolving things over time. Higher temperatures usually accelerate these reactions, so when you start having climate change raising temperatures, you can just start having more of this. There are some natural sources of sulfur dioxide I'd like to mention. So it's not purely something that is like acid rain is not purely a man-made thing. Acid rain does exist in the wild, I guess to say, so it's something that naturally happens. One big, not famous, but one common example of it is that sulfur dioxide is actually emitted by volcanoes when they erupt. But obviously, volcano eruptions aren't something that happen every day, so it's a much rarer occurrence and it's not as concentrated as it is now due to industrialization. So this is an example of more is just the problem. Next topic here, and I think this is the last topic we're touching on, is extreme weather events. So weather events have become more intense and they become more frequent as climate change influences the world. These are the more terrestrial ones we're going to be talking about. There's obviously many, many more that we're going to be talking about next week in the aquatic environment part of this whole climate change discussion, because obviously there's floods, there's hurricanes. Those are two big ones that are more aquatic based as opposed to terrestrial based. Although hurricanes obviously can have their impact on the terrestrial environment, and same with floods. They're primarily aquatic in terms of how they originate. So heat waves, the first one we're going to talk about, is basically increasing greenhouse gases are causing hot days to be hotter and more frequent. They can impact other disasters because they can increase the severity of droughts. If it's hotter, then water will evaporate quicker, if there is any water, in which case when you have a drought, probably not. They can also increase the severity and the likelihood of your wildfires, which just makes them spread more or just start in more places and conglomerate together. And they can also cause heat stress in people. Livestock and crops can also experience heat stress. And the higher temperatures can also have the added impact of increasing electricity demand for cooling from air conditioners and lower ability of transmission of lines to carry power, which can mean that not only are people getting more heat stress, not only is there potential for more disasters, but we're also burning more fossil fuels just to create the electricity needed to cool off when we go inside. Another one is winter storms. This one might actually seem a little counterintuitive, that climate change would cause more severe winter storms, because normally when we think of climate change, we're thinking about how temperatures are going up. So a warmer planet, in a nutshell, is evaporating more water into the atmosphere, and that added moisture means more precipitation. A warmer planet also means it takes longer for lakes to freeze over. Remember how, I think it was last week, I said that water is an excellent heat reservoir. So when cold air masses move across warmer lake water. The lower layer is warmed up by the lake, and it picks up water vapor, which rises up through the colder air. This vapor then freezes in the colder air and is deposited as snow, and it's known as the lake effect snow. During the colder months, this added precipitation is shown as the massive winter storms we experience. Likewise, if you have more massive winter storms or more dangerous winter storms during the winter, it makes sense that during the summer, during the spring, during the fall, in the warmer months, you have more severe thunderstorms. They work pretty similarly. The warmer air is able to hold more moisture, though, so rainfall intensity increases as temperatures rise. Severe thunderstorms are not only dangerous for the rainfall they can produce, but also their ability to transform into tornadoes or supercells. The intensity is a function of volume over time. So that basically means how much rain falls and how quickly. So for instance, a storm that has 25 millimeters of rain in 1 hour is much more intense than a storm that emits 1 millimeter of rain every hour for 25 hours, even if the total volume for both of those storms ends up being the exact same. This also puts a very, very different amount of strain on our city infrastructure. So this is called an IDF curve, which basically stands for intensity, duration, frequency. And it's basically a way of giving storms a term to define their relative frequency. So you can see along here, you got your 100, 50, 25, 10, 5, and your 2-year storm. And they are denoted by the intensity or the duration, the intensity and duration of the rainfall. So if we're looking at, for instance, this 100-year storm, you're looking at, and this is in inches, mind you, just over 12 inches in like 20 minutes. Which is nuts. So the longer it takes for a storm to happen, so in this case 100 years is a lot like longer duration between two events, the more dangerous or the more severe or intense the storm is. And when I say a 100-year storm, it doesn't mean that on the mark or on the ball every 100 years you're going to have a storm. If we had a 100-year storm tomorrow, it doesn't mean exactly 100 years from then we'd have another one. It just means relatively or average, on average, they're roughly 1 in 100 years. They're just rarer. Likewise, a 2-year storm, you probably get roughly once every 2 years. You could have more than one in a single year. You could have 2 in 1 year, but that just means that over a greater period of time, when you're looking at the average of everything, that it roughly averages out to once every 2 years. And why is that important? Our city infrastructure, it just can't handle increasingly more common intense storm events. As climate change increases, as I mentioned, the warmer climate is going to cause more intense rain events. And city infrastructure, not to kind of throw them under the bus or anything, is typically designed with, what's the way of putting this? Not to the cheapest specifications, because that just sounds mean, but they kind of do like a risk reward analysis to it. So what's the least amount of money they can spend that's going to satisfy the most risk, if that makes sense. So storm pipe and sanitary pipe infrastructure, which is both storm infrastructure to handle rainstorms and sanitary, which is to deal with, your poop and your showers and that kind of stuff. They weren't made to handle climate change in mind. They weren't made with that in mind. They were, in some cases, some of the pipes that are sitting even under Barrie are like 50 to 100 years old. So that's why sometimes you'll start seeing renovation projects to start putting in bigger pipes. That's also due to, increased residential areas being built up. So, they need to expand that kind of thing. But basically, if you have a pipe, say, that can only handle up to a 50-year storm, right? And anything beyond that, we're in trouble, because then the pipe's going to just overflow and you're going to get basically what this picture is looking at here. I'm sure nobody wants to look out their window in the morning when it's raining out and see, a bunch of poop or something flowing down the river, flowing down the street. So with more frequent and high intensity events beginning to happen, more intense storms more frequently, that's putting a heavier load on our system. a sanitary system could very well more likely handle, as that example I gave, a couple minutes ago, something that rained 1 millimeter every hour for 25 hours. It could handle that much more easily because that's a lighter load over a long period of time, as opposed to just dumping 25 millimeters on us immediately. Droughts is another big one. So as a place heats up from climate change, drought is an inevitability that people will often think about. It's usually defined as a deficiency of proficiency over an extent. I think I had a typo there or something. Usually defined as deficiency over an extended period of time, resulting in a water shortage. The southwestern United States has already seen a decrease in annual precipitation since the beginning of the 20th century. And generally speaking, on a global scale, drier places will get drier and wetter places will get wetter. So that's not to say that if you are living in a marsh, first off, why are you living in a marsh? That's a terrible idea. But second off, the marsh is probably not going to dry up anytime soon. But spots that are kind of dry to begin with, they'll just, and especially as desertification becomes more of an issue, then you're going to start seeing more droughts. You can see there are droughts throughout the world, and probably in spots you probably didn't think about. In fact, northern Ontario and the prairie provinces themselves are currently experiencing droughts. And droughts exacerbate other problems, other problems as well. They cause crop loss, right? Because you're not getting enough water to your crops. They cause habitat damage because now the creatures that need that water, whether it's because of the ponds they live in or the lakes or what have you, they don't, like, things dry up. Increased costs for food and water because, again, if you're having crop loss, there's less of it, and you still have supply and demand, still a capitalist society. You have increased human health risks. You have reduced incomes, rise in drought-related deaths. Increased soil erosion is another one, throwing it back to near the beginning of our presentation. Droughts can cause a lot of problems. Even just thinking of the droughts that have been in California, they contribute to the wildfires that continue to rage through the countryside due to the drier conditions, but also they also don't even have the water then to fight the fire in the first place. That brings us to the end. So next week, we're going to be talking about the aquatic environment presentation. So that's the final, presentation as far as climate change is concerned. And then we have the Before the Flood video assignment due, which kind of goes hand in hand with the aquatic environment. Essay assignment number 2, so the wildlife and climate change, that is due tonight at midnight. The Before the Flood video assignment's due tonight. What am I talking about? One Ocean is with aquatic environment. Nix everything I said before. Let me start from the beginning. So aquatic environment presentation we're going to have next week. Tonight, we have the Before the Flood video assignment and essay assignment number 2, both due tonight at midnight. And then we have the One Ocean video assignment. That one is with the aquatic environment presentation. That will be due Friday, April 15th at midnight. And then finally, we have the final test available, the final exam, on Monday, April 18th. That will be available the entire day for you. You'll have a 2-hour span to complete it. It'll be very similar in structure to the midterm, so it'll be multiple choice and true or false. Don't know how many questions it is off the top of my head, but I want to say, you know what, I'm not even going to say. I'm not sure. I'm not entirely sure yet. But that will be available, as I said, Monday, April 18th for the entire time. You'll have 2 hours, but you will have to complete it in one sitting. You can't just, start it and then, pause it, go have a coffee or something. So once you start it, make sure you've got that 2 hours set aside for yourself so you can complete it. That being said, the green technology assignments have been all handed in as far as I can tell. If you haven't handed it in yet, please do so as soon as you can. I'll be marking those shortly, probably over the weekend. And then, I'll get started on the essay assignment number 2. I'd like to and same with the Before the Flood video assignment. I'd like to have everything marked for you going into the final test. That might not be possible just for the video assignment because that's giving me a pretty short turnaround time, but I'll do my best for you guys. As always, if you have any questions, any concerns, any inquiries, any feedback, anything whatsoever that suits your fancy, please reach out to me. I've been in contact with quite a few of you through email, which has been fantastic. especially with like due dates and stuff like that. If you're not sure about you're going to reach it or not, just, like I said, just reach out to me. I'm always pretty flexible with that stuff. Real life, as far as I'm concerned, always comes first. So if you have legitimate reasons for why you can't make a due date, then please feel free to reach out to me. That being said, that brings us to the end. I've got nothing left. I'm all out of words to say. So yeah, I'll talk to you guys next week. And as always, I'm Michael LeClaire. Thanks for watching.